First, A intersection B is equal to B intersection A. A is equal to 1, 2, 3, 4 and B is equal to 4, 3, 5. A intersection B is equal to 4, 3 and B intersection A is equal to 4, 3. Therefore, A intersection B is equal to B intersection A. Second, A is a subset of B, then A is intersection B is equal to A. A is equal to 1, 2, B is equal to 1, 2, 3. A intersection B is equal to 1, 2. Therefore, A intersection B is equal to A. Third, A intersection B is equal to B. Then B subset of A. A is equal to 1, 2, 3, 4, 5. B is equal to 1, 3, 5. A intersection B is equal to 1, 3, 5 and B is equal to 1, 3, 5. Therefore, A intersection B is equal to B. Here B is a subset of A. Therefore, B is a subset of A. Fourth, A intersection B is a subset of A and A intersection B is a subset of B. A is equal to 1, 2, 3, 6, 9 and B is equal to 1, 6, 9. A intersection B is equal to 1, 6, 9. Therefore, A intersection B is a subset of A and A intersection B is a subset of B. Fifth, A intersect with A's complement is equal to 5. U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A is equal to 2, 4, 6, 8, 10. A's complement is equal to 1, 3, 5, 7, 9. A intersect with A's complement is equal to empty set and A's intersect with A's complement is equal to 5. A intersection A is equal to A. A intersect with A is equal to 1, 2, 3, 4. Intersect with 1, 2, 3, 4. A intersect A is equal to 1, 2, 3, 4 is equal to A. Therefore, A intersect A is equal to A. A intersect with 5 is equal to 5. A intersect 5 is equal to 5. Set of 1, 2, 3, 4 is intersect with null set is equal to null set. A intersect 5 is equal to 5.